In the previous video, we learned how to improve the user experience by implementing background and main queues. In this video, we'll introduce Grand Central Dispatch, the low-level API that NS Operation Queue uses under the hood. We'll learn why some developers choose Grand Central Dispatch over NS Operation Queue, and we'll replace our operation queues with Dispatch Async calls. Under the hood of NS Operation Queue lives Grand Central Dispatch, one of the lowest level APIs that you may ever work with as an Apple developer. Grand Central Dispatch, or GCD, is such a low-level API that it's essentially baked into the operating system kernel. What this should mean to you is that it's extremely efficient and requires very little code to use. GCD is like NS Operation Queue in that it allows you to specify tasks to be performed as blocks and schedules them to be processed. Moreover, these queues are dispatched as serial queues, which means that GCD manages locking and unlocking for you, which eliminates the possibility of unintended cross-thread mutation of datasets. If Grand Central Dispatch is so efficient, why would one even bother with NS Operation Queue? There are a few schools of thought on this, and I encourage you to follow this link to an excellent discussion on the topic. Essentially, NS Operation Queue provides a high-level abstraction that offers some convenient features that GCD alone doesn't. The trade-off, however, is that NS Operation Queue is a COCO object that requires a non-trivial amount of overhead to use, as it must be allocated and deallocated. If you're working with just a few instances of NS Operation Queue and top performance isn't an issue, it might be the appropriate choice. However, if you're dispatching many blocks to queues, then you probably don't want to be allocating and deallocating over and over again, and in that scenario, GCD is the right choice. At the end of the day, top professionals use either one, so the choice is entirely up to you. Having said that, let's go ahead and replace our NS Operation Queues in our Game of Life app with GCD. Once your project is loaded, open up HighScore Table View Controller, and let's remove the NS Operation Queue from our Property Observer. We'll replace it with a call to Dispatch Async. Dispatch Async is a C API call that allows us to interface with GCD. You'll use Dispatch Async in about 90% of your GCD work. What Dispatch Async does is it appends our specified task in the form of a closure onto a queue and then returns immediately. Notice that Dispatch Async takes two parameters, a queue and a block. Since this is the code that updates the user interface, we're going to make sure it's done on the main queue. We specify the main queue by passing in a function named dispatch_get_main_queue as the first parameter. Then our second parameter is a closure that contains our code. Simple enough. Let's build and run to make sure everything works. We'll navigate to our Most Iterations tab and wait for it to load. And as expected, our interface is properly updated. Now let's go ahead and replace the other operation queue that's in connect.swift with GCD. Start by removing the code that we implemented earlier and replacing it with another Dispatch Async call. This time, we want to get the background queue, so we'll pass in a parameter to Dispatch Async of dispatch_get_global_queue with 00 as its parameters. And we'll wrap the closure around the code we want to run in the background. We'll discuss this dispatch_get_global_queue function in more depth in the next video, but for now, let's test our application. Build and run. Once our simulator loads, navigate to the Most Iterations page and test the UI for responsiveness. In this video, we've replaced our operation queues with more efficient GCD dispatch queues. In the next video, we'll take a closer look at Grand Central Dispatch's dispatch queues.